my dear friends. I hope you all are doing fine. So now let's start our 13th video lesson of class 9 physical science. Hey, students, all of you guys are interested? Right. So now let's start this class without any further delays. Today, so students, this is the poster for you. So what you can make out from this poster? What you can interpret from this poster, students? Yes? Right. So this picture represents that this ear is hearing some sound, but this ear is not hearing any sound. Okay, students, that is what we can think about this picture. But have you ever wondered why it is happening? Okay, now let's see this picture. What is this? Yes, this is the pendulum, isn't it? This is the pendulum. But can you hear a pendulum oscillating? Can you hear a pendulum oscillating? No, you cannot hear a pendulum that is oscillating, right? So students, why is some sound audible to us but some sounds is not audible to us? So what is the relation between these things, right? What is the difference between the audible sound or inaudible sound, right? So on the basis of the sounds that we can hear or we cannot hear, we have classified the sound into two categories, right? And these two categories are audible sound and inaudible sound. Okay. So now let's see what is audible sound and let's see what is inaudible sound. Okay. So now see, sound can be classified into audible and inaudible. Okay, the sounds that we can hear, these are called as audible sound, right? The sounds which we can hear, it is called as audible sound, and the sounds which we cannot hear, this is called as inaudible sound. Okay, students. So in the case of audible sound, the frequency will be where the frequency will be 20 hertz to 20 kilohertz, right, students? The frequency of the audible sound will be 20 hertz to 20 kilohertz. But in the case of inaudible sound, it will be it will be either less than 20 hertz or it will be more than 20,000 hertz, right? Or we can say 20 kilohertz, right? So remember, this classification is for humans only. Understood, students? This classification is only for the humans. So this is the human audible range. So what is the human audible range? Human audible range is 20 hertz to 20 kilohertz. Okay, students? Right. So which sounds are inaudible to humans? So the sounds which are below 20 hertz or the sounds that are more than 20 hertz, 20,000 hertz, these are inaudible to humans. Okay, students? Right. So now just see this picture. What you can see? Yes. So from this picture, we can see that elephants can hear the sound that is below 20 hertz. Okay, students? The elephants can hear the sound that is below 20 hertz. We humans, our hearing range is 20 hertz to 20 kilohertz, right? Our hearing range is how much? It is between 20 hertz to 20 kilohertz, or we can say 20,000 hertz. But we know that bats, the bats that is flying around your house, or sometimes you can find those bats roaming around in at the top of your roof. That bats can hear a sound. That a sound should be more than 20,000 hertz, right? So bats can hear those sounds, right? So now there is the question for you. So the question is, what is the audible range of humans, right? So students, think about this question for 10 seconds. Then I will ask you for the answer. Okay, students? Right. So what is the human audible range, students? Yes? Right. So the human audible range is 20 hertz. It is 20 hertz to 20,000 hertz, right? It is 20 hertz to 20,000 hertz, right? Yes, students. Now, how can we differentiate between the ultrasonic and the infrasonic waves? we know that the human audible range is 20 hertz to 20,000 hertz. So the sound that is less than 20 hertz, it is called as infrasonic, right? And the sound that is more than 20,000 hertz, it is called as ultrasonic, right, students? The sound that is below 20 hertz, we call it as infrasonic, and the sound that is above 20,000 hertz, we call them as ultrasonic sound. Right, students? Now, let's look at this picture. So, students, here in this case, in this picture, you can find that in the infrasonic waves, the frequency is below 20 hertz. Yes. So, here the frequency is 16 hertz, right? So, in the case of audible frequency, the frequency is between 20 hertz or 20 to 20 kilohertz, right? So, this is the audible frequency, right? And this is the ultrasound, and you can see these crests and troughs are arranged in a very close proximity, indicating that it is an ultrasonic sound. But students, have you ever wondered like what is the function of this ultrasonic waves, ultrasonic sound waves, or we can say ultrasound waves? Yes, you might have seen this type of pictures in movies, or in your homes also. If someone is pregnant, then you might have seen this type of picture. They go to a doctor and they do a procedure called as ultrasonography. And in the ultrasonography, you can see this child type of thing is being seen, isn't it? So there is a device that transmits a ultrasonic signal, ultrasonic wave that crosses our skin, and it generates a signal, or we say an image. Okay, students? Right. So what are some other functions of this ultrasonic waves? Can you think about some functions of this ultrasonic waves? Yes, students? Right. So now let's look at the functions of the ultrasonic waves. Right. So the functions of the ultrasound waves are, first of all, it is used to clean parts that are hard to reach, right? So suppose that there is a spiral tube and you cannot reach there with your hand or with or any brush. So then what you will do, then you will use an ultrasonic cleaner, and that ultrasonic cleaner will do what? That will do the cleaning for you, right? So ultrasonic waves can be used to detect cracks and flaws in the metal blocks, right? So ultrasonic waves are used to detect cracks or flaws that are present in the metal blocks. So how we can see where is the defect in the metal blocks by using ultrasound? Let's see this. So students, what happens here? The ultrasound is being transported, ultrasound is being passed through this, right? And if the metal block is all right, then what will happen? This ultrasound will pass right through and it will be picked up by the detector. But when there is a crack in this metal block, then what will happen? The sound will bounce back, and this detector will does not listen anything, and then it will direct that this place is having a crack. Okay, students? Right. So other important fact is that the ultrasonic waves can be used to break the stones of the kidney, right? Sometimes what happens, due to the deposition of some chemicals in our kidney, specifically calcium oxalate, what happens? There is a formation of stone in our kidney, right? So sometimes when when the stones are small stones, then those stones can be treated by using the ultrasound waves. So we apply the ultrasound waves and it causes disturbance in the stones, and that stones rub against each other and it breaks down, right? The sound breaks down the stone, right? So now we have seen that the ultrasound waves can do what? We can clean things, right? We can detect the cracks in metals. We can break small kidney stones present in our kidneys, isn't it, students? Yes. So these are some of the functions of the ultrasound waves. So now, students, let's see how the ultrasonic waves are used to like detect the cracks, right? We have already seen in little bit detail, so now we will elaborate it further. Okay, students? So students, we see that when ultrasound waves are passed, it will pass right through the metal block. Right students? It will pass right through the metal block if the metal block is alright. Okay. But if there is a crack in this metal block, even a small defect, then what will happen? This ultrasonic wave, this ultrasound wave will get bounced back, right? When it will get bounced back, then you can know that yes, at this position in the metal sheet, there is some type of obstruction. Okay, students? Right. So now let's move ahead to our next slide. So there is a quiz for you. Okay, students? So the quiz is you need to list three applications of the ultrasound waves. Okay? You need to list three applications of the ultrasound waves. Yes, I'm giving you 30 seconds. You can think about this question. Then I will ask you the answers. Okay? Right. Yes. So the first application of the ultrasound waves can be first, it can be used to clean hard to reach places, right? Ultrasonic waves can be used to clean hard to reach places like spiral tubes, etc. So whenever we are finding it hard to reach at some place, then we can use ultrasound waves to clean that place for us. Okay. After that, what is the another use? The ultrasound waves can be used to detect the flaws in the metals, like if the metal has bent, or if the metal has cracked, or if there is a small hairline fracture in the metal. So these type of defects can be picked up by the ultrasound waves. Okay, students, right? So this was the second application of the ultrasound waves. Now coming to the third point. So students, we know that sometimes in our kidney stones get formed, right? So to remove that stones, we use ultrasound waves that breaks down the stones in the kidney. So that was the third application of the ultrasound waves. Okay, students? Right. So now let's proceed ahead. So students, what you can see in this picture? Yes, we can see that this ship is releasing some sort of sound, a type of sound, and this sound is getting below the sea. It is then it has hit something, and then it is returning back, right? So this is what we have saw in this picture, isn't it, students? Yes. Okay, now just see if you can find anything more in this slide. Right. So students, now we are going to learn about a topic, and that topic is sonar, right? That topic is sonar, SONAR. The full form of sonar is sound navigation and ranging, right? The full form of sonar is sound navigation and ranging. Okay, so now let's look how the sonar works. Okay, students, so see, we can find the depth of the sea by using sonar, or we can find the depth of anything by the means of sonar, right? So what happens? There is a transmitter. This is a ultrasound wave transmitter, and this is a receiver, right? This is the receiver. So what happens, students? This ultrasound transmitter transmits a sound, right? This transmits a sound, and when it strikes any surface, when this sound strikes any surface, we know from the laws of reflection of sound that the sound is getting reflected, right? So sound can get reflected. So this sound is also getting reflected. I'll use the red coloring. So now the sound is getting reflected, and it will reach where? It will reach the detector, right? So once it has reached the detector, then what will be done? Then we can like calculate like how many seconds before we have sent that sound, and how many seconds after that the sound has reached us again, right? So In that time period, the sound has traveled twice the distance of that object of the depth of the ocean. So we can calculate the depth of the sea by using the sonar. Right, students? Okay. So students, we saw that the transmitter produces and that transmits ultrasonic waves, right? That these waves travels through water, and after striking in the object of the seabed, these gets reflected back, right? And when they are getting reflected back, these are sensed by the detector, right? And once the detector senses these sound waves, then what it does, it converts them back to the electrical signals which are appropriately interpreted, right? These are interpreted by the means of the computers, right? So the distance of the object that reflected sound waves can be calculated by knowing the speed of the sound in the water and the time interval between the transmission and the reception of the sound. If we know the speed of the sound in water, the time between the reception and the transmission of the sound, then we can calculate the depth of the object. It is a very simple equation to follow. Okay, students? Right. So now you have understood how this sonar thing works. Yes, students? Right. So now, students, who will tell me what is the full form of sonar? Yes, the full form is sonar is sound navigation and ranging. Yes, the full form of sonar is sound navigation and ranging. Right. So now let's proceed ahead. So students, what is the full form of sonar? Who will write it here? Yes. So the full form of sonar is sound navigation and ranging. Right? So this is the full form of sonar. Okay, students? Right. So the next question is sonar helps in finding depth of the seabed, underground valleys, hills. So is this statement a true statement or a false statement? What do you say, students? What according to you is correct? So sonar helps us to find depth of the sea bed, underground valleys or hills. Is this statement true? Yes? Right. So this statement is true. We use sonar to find the depth of the seabed, to locate underground valleys, underground hills. We use sonar. Okay, students? Right. Now, what we have learned in our today's class, students? So in our today's class, we have learned about the audible in and the inaudible sound, right? We have learned about the audible and the inaudible sound. We have also studied about the function of the ultrasonic waves and sonar. Okay, we have also studied about what? The function of the ultrasonic waves and sonar. So now, what is the difference between the audible and the inaudible sound, students? Yes. Right. So the difference is of frequency, right? The audible sound is having the frequency between the 20 hertz and 20 kilohertz, or we can say 20 hertz and 20,000 hertz, right? So in the case of inaudible sound, the frequency will be either less than 20 hertz or it will be more than 20,000 hertz. Right, students? Yes. So what are the three functions of the ultrasound waves? Who will list the three functions of the ultrasound waves? Right. So the three functions of the ultrasound waves are, first of all, it is used to clean hard to reach places. Yes, students? Right. It is used to clean hard to reach places. Yes. After that, we can say that ultrasonic waves are used where it is used to break the kidney stone, right? Ultrasonic waves are also used to detect flaws in the metals, right, students? Yes. So what is the full form of sonar? Yes, the full form of sonar is sound navigation and ranging, right? So how we can measure the depth by the use of sonar? Right. So basically there will be a ship, right? There will be a ship. It will be having a transmitter and a receiver. The transmitter will transmit the signal. It will bounce back from the surface of the ocean or depth of the ocean, right? And it will be picked up by the receiver, right? So now we can calculate, if we know the speed of the sound in water, and the time period between the sending of the signal and receivement of the signal, then we can like calculate what is the depth of the seabed, right? Okay, so what is the function of sonar, students? What is the function of sonar? Right. So the sonar is used to detect the depth of the sea. It is used to find if there is anything beneath the sea, like underground and underwater valleys or hills. Right. So the sonar is used to find these things. Right, students? Okay, so now let's come to the homework section. And in the homework section, what you have to do is you can try to find out that do bats produce sound, and are you able to hear it? If you are not able to hear the sound produced by bats, so why? You need to give reason to it. This is a small homework from my side. So that's all for today. Have a nice day, students.